Hello ladies and gentlemen. What we're going to talk about today is really just a continuation of our last lesson, which is over stoichiometry. What I'm going to do today is I'm going to go through a few example problems with you, then I'm going to give you a chance to practice those problems on your own. So kind of the objectives for today, again, you can answer your bell work, take some time to look through that, and then come back to this video. The objectives that we're going to be looking at today is you're going to be expected to be able to balance a chemical equation. So that's subobjective 1, be able to balance a chemical equation. Subobjective 2 is to be able to identify the mole ratio in a balanced chemical equation. And your goal for today, again, kind of our overarching goal of stoichiometry, is to be able to convert from a given unit to a desired unit using the chemical reaction. So it could ask you to go from grams of one substance to moles of another. Really, there's a lot of different examples. We're going to try and hit a lot of those examples today. So remember, you should have kind of a mole map like this. Again, this is the key, just like your mole map on when we did conversions between liters and grams and particles to moles. Okay, remember that mole map? We're just expanding on that. And so we're going to be using kind of this mole map. I'll be referring to it a lot today. So your ability to be able to use this will really, really help you in doing these stoichiometry problems. So let's go ahead and get started. So here's your first problem. It says calculate the moles of oxygen gas produced when 10 grams of hydrogen peroxide decomposes. Now, just to review, remember there's a logical process, a step-by-step process to doing stoichiometry problems. The first thing you need to have is you need to have a balanced chemical equation. So you should always ask yourself first, is this equation balanced? Yes, it is. There's 2 hydrogens on each side, there's 2 oxygens on each side, so it's balanced. The next thing that you're going to do is you're going to identify your given and your asked for substances, or your desired substance. So I'm going to label those A and B. A is the substance we're given, B is the substance that we're trying to find. So we go back to our problem and it says, calculate the moles of oxygen. That's what we're looking for. We're looking for oxygen. So you have to find, in your equation, find oxygen. Then that will be produced when 10 grams of hydrogen peroxide decomposes. So we have to find our hydrogen peroxide. So hydrogen peroxide, it gives us a gram amount of hydrogen peroxide. So that's going to be our substance A, and our oxygen will be our substance B. Okay, again, A is what we're given. It gave us grams of hydrogen peroxide. B is what we're looking for. Okay? So now I'm going to go to my mole map and I'm going to identify where I am and where I am going. So I am in grams of substance A, or grams of hydrogen peroxide. It asked me to find moles of oxygen. Okay? So I'm going to go back to my mole map. I am in grams of A. So I am here. This is grams of hydrogen peroxide. And it asked me to go to moles of oxygen. So I'm going to go to moles of B. So I'm going to change from mass of hydrogen peroxide to moles of hydrogen peroxide. Then I'm going to use my mole ratio to get to moles of my oxygen. So here we go. So I've got 10 grams. What I'm going to do is I'm going to start with my 10 grams of my H2O2. Again, that's what I'm given. So I'm going from grams to moles of A to moles of B. So to change grams to moles, I divide by the molar mass. So I'm going to divide by the molar mass of H2O2. The molar mass of H2O2, when I add that up, is going to be 34.02 grams. So that's my first step. I've done my first conversion. I just converted from mass of A to moles of A. Now I'm going to convert from moles of A to moles of B using my mole ratio. Okay, so every one of these has a 1 in front of them, which means my mole ratio, again, my moles of, remember, my mole ratio is B over A. So I'm going to do my moles of substance B. So I have 1 mole of O2 for every 1 mole of H2O2. Now, this is where I stop. Here's how I know. When I go through and I cancel out my units, my grams of H2O2 are going to cancel, my moles of H2O2 are going to cancel, and I'm going to be left in moles of oxygen. That's what the problem asked me for. It said calculate the moles of oxygen gas produced. Okay? So now I'm just going to solve this. So I do my 10 divided by 34.02. And then because these are all ones, I don't really need to do those calculations because it'd just be 10 times 1 divided by 34.02 times 1 divided by 1. So those ones don't have any influence on my number. So I should get that I have 0.294 moles of O2. Okay, and that's my problem. Okay, let's look at our next one. So, again, our next problem says how many molecules of isopropyl alcohol are required to mix with 2.5 moles of oxygen gas during combustion. So again, we check, is our equation balanced? The answer is no. Okay, so we need to balance this equation. So I've got 3 carbons here, and I only have 1 carbon here. So I'm going to have to add a 3 there. Then I have 8 hydrogens here, which means I need 8 hydrogens here, so I need to put a 4 here. So I'm going to have a 3 here, a 4 here. Then I go back and look at my oxygens. Now, this is going to be, I'll have a 3 here, 4 there, so that gives me 6 oxygens here, plus these 4 oxygens. So I have 10 oxygens. Now the issue here is I have an odd number on this side. So since I have 10 oxygens on this side now, the only thing I could do is put like a 4. Well, that would only give me 9 oxygens, and I need 10. But if I put a 5, that would give me 11 oxygens. So what do? I need like a half. So this is one of those instances where we have to go through and we're going to put a 2 in front here, and we're going to multiply all our subscripts that we originally had. So instead of this 3, I'd have a 6. Instead of this 4, I'd have an 8. And what you should end up with is this is your balanced chemical equation. So our equation is now balanced. Next thing that we do is we have to identify our given and our asked for substances. So it says that we have 2.5 moles of oxygen gas. Okay, so I have 2.5 moles here, which means this will be my substance A, and it asked me for how many molecules of this compound. So that means this will be my substance B. Now, I look at my mole map to determine where I'm going to go. So I'm given A, I'm going to B, I'm in moles of oxygen, so I'm in moles of A, and it asks me for molecules of B. So I'm going to start here, I'm in moles of oxygen, and it asks me to go to molecules of isopropyl alcohol. Well, molecules is also another name for particles. So I need to convert from moles of A to moles of B using my mole ratio. Then I'm going to convert from moles of B to particles of B using Avogadro's number. So, here we go. So, I have 2.5 moles of O2. I'm going to multiply by my mole ratio, which again is B over A. So it is 2 moles of this compound for every 9 moles of O2. Notice how my moles of O2 are going to cancel out. Next step is I need to, anybody remember? I just converted from moles of A to moles of B using my mole ratio. Now I need to go to my particles because it asked me for molecules, and I'm going to multiply by Avogadro's number. Now when I multiply by Avogadro's number, I'm going to put 6.02 times 10 to the 23rd molecules And then on the bottom we'll go 1 mole of my C3H7OH. Those units will cancel out. And again, the reason why is because in every 1 mole of C3H7O7, there's 6.02 times 10 to the 23rd molecules. And that should be it. We did 2 conversions. It asked us to find molecules, and our units left are in molecules. So now we just need to do our calculation. So I'm going to do 2.5, my starting number, times 2, divided by 9. Then I'm going to put times, and again, make sure you use parentheses around this. Anytime you use a number in scientific notation, use parentheses. Times 6.02 times 10 to the 23rd. And I should get 3.34 times 10 to the 23rd molecules. That should be my answer. That's how many molecules I should have. Okay? Let's try one more, then I'll give you guys a chance to do some practice on your own. So, here's our next question. What volume of oxygen gas at STP is needed to react with excess NO gas to form 3.5 moles of NO2 gas? So, step 1, is our equation balanced? Yes, it is. Okay. Step 2, identify our given and our desired substances. So, it gave us 0.35 moles of NO2 gas. So we know how much NO2 we have. That's our substance A. It says what volume of oxygen. That's our substance B. Now our next step is we go to our mole map and we look to see where we're starting, where we're finishing. So again, we are in moles of NO2. We need to go to volume of oxygen. So we are in moles of NO2. We're in moles of A. That's our substance A. We labeled it as substance A. That's our moles of A. And we are going to volume, which is going to be liters of O2. So we're going to convert from moles of A to moles of B using our mole ratio. Then we're going to convert from moles of B to liters using our 22.4 liters conversion. So here we go. So I have 3.5 moles of moles of NO2, and I'm going to multiply by my mole ratio, which is B over A. So I have 1 mole of O2 for every 2 moles of NO2. Remember, it's always substance B, which is O2, over substance A. Don't forget that. Reversing that fraction obviously will mess up your problem. Then my next step is to convert from moles of substance B, again, moles of NO2 are going to cancel out. Now I'm going to convert from moles of O2 to liters of O2, and how I do that is by multiplying by my 22.4 liters for every 1 mole. So in other words, 1 mole of O2 gas has a volume of 22.4 liters. So now I'm going to cancel out those units, 1 mole of O2. And now I should be finished. Now I just need to do my math. So I'm going to do 3.5 times 1, which does nothing, divided by 2, times 22.4 divided by 1. And again, those 1s don't have any effect on our number. So I've got 3.5 divided by 2 times 22.4. So my answer should be 39.2 liters should be my volume of oxygen gas. So what I want to do now is I'm going to give you guys a chance to try a few problems on your own. Now the answers will pop up on the screen. so that you can see how you've done. If you have any questions, please make sure you let me know. I would suggest that you write down your dimensional analysis on your paper so that way when I come by, I can see your work and I can hopefully help you. So finish those problems, and then once you're done, again, ask me questions. Thank you for watching this video.